physics. We're going to look at the difference between a light dependent resistor, LDR, and a thermistor. Now, the light dependent resistor, as the name says, it's related to light, and thermistor is related to temperature. So I have a resistor that's dependent on light and a resistor that's dependent on temperature. Diagrams, the symbols would be the symbol, these are symbols of resistors. The thermistor gets what I call a hockey stick, and then the LDR kind of shows that the light is going to hit on it. So how are these working? They can both be very high resistant materials, or they can have low resistance dependent on the situation. Now I'm going to do the graph, and then we're going to check them in a circuit. So if I have a graph of resistance over light, and I have a graph of resistance over heat. Now this graph looks like that. An inverse relationship, an inverse proportion. That means this part is where the darkness is. This is resistance high, and that is resistance low. Again, let me put it here, high resistance, low resistance. This is heat, and this is hot, and that is cold. Okay, so what do we have here? In the dark, we have a high resistance. So the LDR will have a high resistance in the dark, and in the light will have a low resistance. If we look at the graph, we see that in the dark it's a high resistance, in the light it's going to be a low resistance. A thermistor in a hot environment would have a low resistance, and when it's cold will have a high resistance. So when it's cold it has a high resistance, when it's hot it has a low resistance. Okay, now let's put them in a circuit. So we have a circuit made of light bulb, it doesn't matter, it can be a resistor if we want, and then we have the LDR, and then here we're going to have another light bulb. A light bulb, thermistor, positive, negative. Here we have another light bulb. Okay, so if we get the current direction from positive terminal towards negative terminal, from positive towards negative, what's happening here? When it's dark, this resistor has a high resistance, but we want to be able to turn on this light when it's dark. So when it's dark, the current can go through the first bulb, but then here when it reaches this point it has two options. It can go through the resistor or it can go through the bulb. Now in the dark this LDR has a high resistance, so practically the current goes through the first bulb, and instead of going through the resistor will go through the bulb. And then it's going back and then completes the circuit, and this bulb is on. And the other one is also on. When it's light, well, this LDR has a low resistance, and then so when the current comes, instead of going through the second bulb, well, it's just going to go to the first bulb and then it's going to go straight on and will complete the circuit. But here, instead of the bulb, let's put another resistor. I think it's better, otherwise it would be a bit confusing. When we have a thermistor, the same situation, when it's hot, well, this thermistor has a low resistance, so current comes in, goes through the bulb, through the resistor, and then it goes back to the terminal. So when it's hot, it's gonna be low R, which means the bulb stays off. When it's cold, you're going to have high resistance, which means the current comes, but instead of going to because this one will have a high resistance, it would go and it would take the path through the light bulb and it's going to go back into the terminal. So this would be